Each running thread gets its own private stack, so all local variables are kept strictly separate. Take a look at the following code. I have a method here called doWork that outputs 5 stars in a row. I call this method from a separate thread and at the same time from the main program thread. The loop variable I exists twice, once for each thread, so that the threads will not interfere with each other. When I run the program, I get 10 stars as output, just as expected. Now watch this. I introduce a new class member, a static integer variable called I, and I modify the loop to use this shared variable instead. So now we have the interesting situation that both the created thread and the main program thread use the same variable I for their loop statement. What do you think the output is going to be? Check this out. The output is only 6 stars. And the reason for this is that both threads are incrementing the same variable. So instead of counting from 0 to 5, the loops are actually counting from 0 to 5 in steps of 2. And the result of this is that only 5 or 6 stars are printed instead of 10. This is a classic example of what is called a race condition. Two threads are fighting for the same variable, and as a result, the code starts to behave in unpredictable ways. In this case, a simple for loop counting from 0 to 5 suddenly only iterates 2 or 3 times before finishing. The solution to race conditions is a technique called locking, but we'll get back to that in the next section. For now, let's just identify the problem. So, a race condition is when program execution no longer follows a predictable path, and as a result, code starts behaving in unexpected ways. Variables seemingly randomly change their values. For loops stop prematurely. Simple increment statements do nothing or increment by 2 instead of 1. All of these things can happen. 9 times out of 10, these race conditions occur because 2 or more threads are accessing the same variable. So the main takeaway of this lecture is: keep the data you share between threads to an absolute minimum. In the next section, I will show you how to use locking to safely share data between threads.